Today we are going to be taking the question number 4A. We have solved the question number 1, question number 2, number 3, and now we are going to be solving question number 4. So the question there says, find the equation of tangent and normal to the curve x cubed plus x square y minus y cubed minus 7 equals 0 at the point 2, 3. So we have that the point x is 2 and y is 3. So let's see how we can solve this given problem. So I'm going to take the solution. We are asked to find the equation of tangent. So take note, the equation of tangent is given by y minus y1 equal to the derivative dy dx at x1 y1 into x minus x1. So this is what we have. So I'm going to take the first one, the equation of tangent, then later we proceed to the normal to the curve. So for the equation of tangent, we have y minus y1 equal to dy dx, which is the gradient at that given point. The given point 2 and 3, and into x minus x1. So what we need to find, we know y1 to be 3, and we know x1 to be 2. So all we need to find is dy dx at that point. Then we can substitute our values to find the equation of tangent. So first of all, let's write the function x cubed plus x squared y minus y cubed minus 7 equals 0. So all we need to do is to differentiate this and find dy dx. And because we have a function of y, because we have y inside of the given function, so we need to use the implicit differentiation. So let's use the implicit differentiation here. Remember the implicit differentiation, you differentiate each term, you differentiate term by term. So we are going to differentiate this. We have d dx of x cubed plus d dx of x squared y minus d dx of y cubed minus d dx of 7 equals 0. So let's differentiate this term by term. To differentiate this, if you differentiate this, you have 3x squared plus, to differentiate this, we need to apply the product rule here. You can check on question number 2. We have solved a problem like this. We need to use the product rule, because we have x squared multiplying y. So we have to apply the product rule here. And this is our u, this is our v. So we should remember the product rule. The product rule says keep the first term constant. We have x squared, and then you differentiate the second one. If you differentiate y, you have dy dx. Then the next is to add. We keep y constant, and then we differentiate x squared. So we have 2x, and we are done with that part. The next one is minus. If you differentiate y cubed, you have 3y squared. But because y is the dependent variable, so we need to multiply it by dy dx. So we multiply here by dy dx. And if you differentiate 7, you have 0. So to the right hand side, we have 0. So this is what we have. So let's write the point here. The point is 2, 3. So this is the given point. So I'm going to clean this part. Alright, so this part, Firstly, let's send every term that does not contain dy dx. Let's send them to the right hand side. So if you should send 3x squared to the right hand side, you have, okay, first let's write this. We have x squared dy dx, x squared dy dx. The next one we have there is minus 3y squared dy dx equals, if you should send 3x squared over to the other side, you have minus 3x squared. Then you send 2xy to the other side, you have minus 2xy. So let's factor dy dx from here. So we have dy dx into, if you factor out dy dx here, you have x squared. If you factor out dy dx here, you have minus 3y squared. And this is equal to minus 3x squared minus 2xy. So make dy dx subject of formula. You have dy dx equals minus 3x squared minus 2xy over x squared minus 3y squared. So this is what we have. So let's quickly find dy dx at the given points 2 and 3 from the question, from the given point. So what we need to do is to just substitute x, substitute 2 for x and 3 for y. So we have minus 3 into x is 2 square minus 2 into x is 2 and y is 3. And the whole of this divide by x is 2. So we have 2 square minus y is 3. 3 into 3 square. So this is what we have. So dy dx at that point at x1 y1 is equal to, let's evaluate this and see what we have. All right, so evaluating this, we are going to have 24 over 23 as our answer. So we can substitute this here and find our equation of tangent. So let's quickly substitute the value of dy dx at x1 y1. Substituting that, we have y minus y1. We have the point 2 and 3. 2, 3. So y1 is 3. So we have y minus 3 equal to dy dx at x1 y1 gives us 24 over 23. So we have 24 over 23 into our x minus x1 is, our x1 is 2. So we can send 3 to the other side. We have y equal to 24 over 23x minus over 23x minus 24 over 23 times 2 will give us 48 over 23 minus plus 3. So we can evaluate this and find our equation of tangent. So let's simplify what we have here to find our equation of tangent. So evaluating this, we have y equal to 24 over 23x plus 21 over 23. And this becomes our equation of tangent. So let's proceed by finding the normal to the curve. Normal Normal to the curve is given by y minus y1 equal to -1 over dy dx at x1 y1 into x minus x1. So this is the formula we are going to be using to find the normal to the curve. So the normal to the curve becomes y minus y1 there was 3, and this is equal to -1 over dy dx at x1 y1 gives us 24 over 23. So we have 24 over 23 into x minus 2. Alright, so this will give us, take the reciprocal of this, you have minus 23 over 24 into x minus 2. So we have y, you send 3 to the other side, you have y to be equal to minus 23 over 24x minus 23 over 24x plus 23 times 2 will give us 46. 46 over 24 plus 3. So let's evaluate this and find our normal to the curve. So we have minus 23 over 24x. Let's evaluate this. If we should evaluate this, we have 59 over 12, and that becomes our normal to the curve, and this becomes our equation of tangent. So let's quickly proceed to question number 4b, so we can move on to question number 5. All right, so still under the question number 4. Now let's take the B part. The B part of the question there says, find all the stationary points of the function y equals x cubed minus 3x squared plus x plus 3 and classify them. So let's begin by finding the stationary points first, and then we classify the points. To find the stationary points, we recall the function y equals x cubed minus 2x squared plus x plus 3. So we should take note that at the stationary point, the first derivative is equal to 0. So we need to find the derivative of this function and equate it to 0 to find the stationary point. So let's find the derivative of this function. So we have dy dx equals, if you differentiate this, you have 3x squared minus 4x plus 1. But at stationary point, dy dx is equal to 0. So we can equate this to 0 and find the values of x. So we have 3x squared minus 4x plus 1 equal to 0. So we want to find the corresponding values of x here. So we can factorize this. We have 3x squared. This can be written as minus 3x minus x plus 1 equal to 0. Because minus 3x minus x will give us minus 4x. So let's factorize this. We have 3x into x minus 1. Then we have minus 1 into x minus 1 equals to 0. So we have 3x minus 1 into x minus 1 being equal to 0. So we have 3x minus 1 equal to 0, or x minus 1 equal to 0. So from here we have x to be equal to 1 over 3 and we have x here to be equal to 1. So this is the stationary point. The question asks us to find the stationary point of this function. So x equal to 1 over 3 and 1 are the stationary points. Then the next is for us to classify the stationary point. So to classify the stationary point, we are going to be using the second derivative test. And for the second derivative test, if the second derivative of the function with respect to x, if it is greater than 0, then we have minimum. Then if the second derivative is less than 0, then we have maximum. So this is just what we are going to be checking for. So we already know the first derivative to be this. So we need to from here and find the second derivative and test for those points. If it is greater than 0, then it is minimum. Then if it is less than 0, it is maximum. So let's find the second derivative of this given function. So we have that the first derivative there was dy dx being equal to 3x squared minus 4x plus 1. So let's find the second derivative. We have the square y over the x squared to be equal to, if you differentiate this, you have 6x, and if you differentiate this, you have minus 4. So let's find the value at x equal to 1 over 3 and x equal to 1. So the next one there is for x equal to 1, we have the square y over the x squared being equal to 6 into 1 minus 4. And this is going to give us 6 minus 4, which is equal to 2. And of course, this is greater than 0. So it means at that point, we have minimum. Then the next one, for x being equal to 1 over 3. 1 over 3, we have the square y over the x squared to be equal to, at x equal to 1 over 3, we have 6 into 1 over 3 minus 4. And this will give us, 6 over 3 will give us 2. So we have 2 minus 4, which is equal to minus 2, which is less than 0. So it means we have maximum here. We have just classified the stationary points of that given question. So let's move on to question number 5 of that same year, 2023.